So having done some now redox reactions for alcohols, now you get to look at some more reaction types. So let's say I take a molecule. I'm going to take CH3, CH, double bond CH, and a CHO. This, if I draw out the skeletal version of this, it will be 1, 2, 3. 3, like something like that. And I have I'm actually making the skeletal version of what I've drawn on top, and the second bond is a carbon-carbon double bond right here, something of that nature. You know, come on. Maybe this will work out. I'll move this right here. Maybe make this a little small. I'm trying to make it nice, but so what I've drawn here, I've also made the skeletal version, and the skeletal version is important. Now, this is the same molecule in both cases. It has two functional groups. Which ones does it have? It has an alkene and an aldehyde. And the reason why I've given these two functional groups because they both have oxidation and reduction reactions. Okay. Different types, by the way. They have, but there are different types. For example, I tell you that I'm going to put this guy in the middle. Okay. Now, one of the first reactions we saw was, let's call it oxidation. So reaction number 1, I'm going to add, let's say, acidified potassium dichromate and heat. Now you might say, Bilal, what kind of heat? Heat and a reflux or heat and distillate of the product? In both cases, the result will be the same. Dichromate does not oxidize alkene, but will oxidize aldehyde. So I'm going to give you 4 reactions that we're going to draw out. Okay, one of them, number 1, was that oxidation. Then we'll try another way of oxidation. The same fellow, what if we try oxidation using acidified KMnO4 cold, let's say at room temperature or cold. Now, normally if I heat with KMnO4, aldehyde also gets oxidized in alkene. But if it's room temperature, only the alkene will get oxidized. While with dichromate, only the aldehyde will get oxidized. And the 2 reduction reactions I'll do in green, horizontally. Now, the 2 reduction reactions are 2 different reducing agents. In one case, it'll reduce only the ketone or the aldehyde. Let's say, for example, I tell you, let's take NaBH4 aqueous and heat. You get a certain molecule. The other case would be take hydrogen and nickel and heat. Now, this is reaction number, let's say 3 and 4. Now, 1 and 2 are oxidation reactions. I've identified 1 and 2 as oxidation. And 3 and 4 are reduction reactions. Okay. 1 will only oxidize the aldehyde. 2 will only oxidize the alkene. 3 will only reduce the aldehyde. 4 will reduce both the aldehyde and alkene. And that's where the questions are becoming fun. You have to judge that where is the reaction taking place. So if I were to take both the functional group, the diagram in terms of both skeletal and displayed, skeletal and what do you call it? Skeletal and let's say structural, and I'll place them in both places. I'll duplicate left and right, and I'll duplicate this on top and the bottom. Now you might say, well, okay, there's no space here. So what I'll do is I'll draw both versions of it so that you guys get used to it. Nowadays, they expect you to only draw skeletal mostly because that's the more efficient version. But even if you draw the other is fine also. At times they'll specify. But now my example number 3, I'm going to just make some more space here to bring them down. So now, the reason I'm doing this with you is that you also see what I'm trying to do here. So I put all these guys right here. Okay. Reaction number 1 and 2 are oxidation, 3 and 4 are reduction. And now I've taken the original reactant, and now we're going to see what happens to that reactant if I oxidize it in one of two different ways, both ways, and if I reduce them. Okay, both ways we'll take a look right now. Okay, so with dichromate, the only functional group that's reduced that's oxidized is the aldehyde, and what will happen is the aldehyde's H will have an extra O add on to it, so that H will become OH. So I'm just highlighting the change, and this double bond H will actually just lose the O, and the O will get an H. So I'll go from being a aldehyde to a carboxylic acid. Now you might say, Bilal, here, why did you put an alcohol here? You're absolutely right. I should have put an acid right there. So wait. So I'll take that O, COOH. So C double bond O, and then OH. So now the alkene stays as is, but the aldehyde becomes a carboxylic acid. Okay. Now, if I had taken hot KMnO4, both the alkene and the acid would oxidize. But now I've taken only cold KMnO4, aldehyde, nothing happens to the aldehyde, but the alkene, what happens to the other oxidation? So the alkene becomes a diol, if you remember. That cold alkaline or acidic KMnO4 breaks the carbon-carbon double bond and adds two OHs on this, becomes a diol. So here I'll remove the double bond and add an OH there and an OH there. Okay. Now, when the other reaction 3 and 4 are reduction. Now NaBH4 reduces only aldehydes and ketones, RCOR dash. So what will happen to the aldehyde? The aldehyde will break the carbon oxygen double bond. One H will go there. So it will become a primary alcohol. H will go there. And to make some more space, I'll move this down. And a second H will come here. Okay, that's the change. Now you might say, Bilal, you did it in green, so do it in green. That's fine also. I can do it in green. So put the H there and an H. So it becomes a CH2OH. To show it here, all I have to do is just show the OH. You don't show the extra H's here. You just remove the double bond and you do that. Okay. But with so now it becomes an alkene and a primary alcohol. So if they ask you functional groups, the original molecule is an alkene and an aldehyde. The product of reaction 1 is an alkene and an acid. The product of reaction 2 is an alcohol, secondary alcohols and aldehydes. Okay, so let's write the functional groups in blue. The functional group for the first one we made was an alkene, which is a carbon-carbon double bond, and a carboxylic acid. Identifying functional groups is important. They'll ask you that. For reaction number 2, these are both secondary alcohols. So there are two secondary alcohols because they are CHOH. You see that? And it's an aldehyde. The aldehyde stays as is. The reactant had an alkene and an aldehyde. Product of reaction number 3 stays an alkene. You know, the alkene, nothing happened to the alkene, but the aldehyde became a primary alcohol. And reaction number 4, hydrogen and nickel will both reduce the alkene and the aldehyde. So what will happen to the alkene is the double bond will get 2 extra H's. You know, it will become CH2s. You won't have the double bond in the skeleton anymore, and the aldehyde will become CH2OH. 2 H's will go there. So 4 hydrogen atoms are being attached here. And the double bond will break, and now you have an OH. So now the only functional group here left, because you don't say alkene is a functional group, you never write that. You just call it a primary alcohol. And now you're going to start getting comfortable with doing these kind of map diagrams. I call these organic web diagrams, but they're really organic synthesis reactions, building one thing from the other.